The most feared fighter in the Pacific had no armor behind the pilot's seat. Not thin armor, not inadequate armor, none. The Mitsubishi A6M Zero, the aircraft that humiliated the United States Navy at Pearl Harbor, that outmaneuvered every Allied fighter it encountered in the first 18 months of the war, was built on a principle so extreme it bordered on institutional suicide. The men who flew it were not protected. They were not expected to need protection. The design philosophy said, if you are hit, you have already failed. That philosophy came from a man named Jiro Horikoshi. It came from a specification issued in 1937 by the Imperial Japanese Navy, and it produced an aircraft so light, so fast, so agile at altitude that Allied pilots who encountered it in 1941 filed reports that their commanders initially dismissed as exaggeration. The reports were not exaggerated. The problem was everything that came after. In 1937, Japan was already at war. Not with the United States, with China. And in that theater, the Navy needed a carrier-based fighter that could escort bombers over distances that no existing aircraft could manage. The specification the Navy issued was, by any engineering standard, impossible. They wanted a fighter with a maximum speed of 500 kilometers per hour at 4,000 meters, a climb rate that would reach that altitude in 3.5 minutes, a range of 3,000 kilometers with drop tanks, and maneuverability exceeding every existing carrier fighter in service. Mitsubishi's chief engineer, Jiro Horikoshi, was 32 years old. He had already built the A5M, the Zero's predecessor, and understood precisely what the Navy was asking. He told them it could not be done, not with the engines available, not with the materials available, not within the weight limits imposed by carrier operations. The Navy told him to find a way. Horikoshi found a way. The way was subtraction. Every component that was not essential to flight performance was removed or reduced to its absolute minimum. The self-sealing fuel tanks that American and British designers were standardizing, removed. The armor plate behind the pilot's seat, removed. The bulletproof windscreen, removed. The structural redundancy built into most military aircraft of the period to absorb combat damage, reduced to the point of absence. What remained was an airframe so light that the same engine powering heavier, better protected fighters could push the Zero to speeds and altitudes its rivals could not match. Horikoshi had not solved the specification. He had made a trade. The pilots would pay the balance. To understand what Horikoshi built, start with what a conventional military aircraft of 1940 looked like from the inside. A standard fighter of that period carried between 6 and 12 millimeters of steel plate behind the pilot, enough to stop rifle-caliber rounds and shell fragments from penetrating the cockpit from the rear. It carried self-sealing fuel tanks, rubber bladders lined with a compound that swelled on contact with aviation fuel, sealing punctures before a fire could start. And it carried structural framing calculated not just for flight loads, but for combat loads, the stresses of high-speed dives, hard turns, and the absorption of non-fatal damage. The Zero had none of this. What it had instead was an airframe built from an aluminum alloy called extra super duralumin, designated 7075, developed specifically for this aircraft. The alloy was harder and lighter than anything then in standard military production. Horikoshi's team used it to construct a monocoque fuselage, a shell structure where the skin itself carries the load, rather than an internal skeleton. Less material, less weight, more strength per gram than any comparable design. The wing design compounded the advantage. The Zero used a laminar flow profile, a shape that reduced drag at high speed by keeping the airflow attached to the wing surface longer than conventional profiles allowed. Combined with the weight reduction, the result was a fighter that could turn inside any Allied aircraft it encountered. At low to medium altitude, in a turning engagement, it was untouchable. Then came the flaw. At speeds above 350 kilometers per hour, the Zero's ailerons, the control surfaces that roll the aircraft, became progressively heavier. The pilot had to fight the aircraft to maintain control. Above 400 kilometers per hour, the ailerons were so stiff that rolling the aircraft took significant physical effort. Above 450, rolling was nearly impossible. This was not a manufacturing defect. It was the monocoque structure. The wing skin, under high-speed aerodynamic load, twisted slightly. That twist worked against the aileron. The faster the Zero went, the less it could maneuver. The aircraft that won by turning could not turn when it mattered most. The aileron reversal problem was documented during test flights in 1940. Test pilots reported it. Horikoshi's engineering team modeled it. The Navy reviewed the findings. The Zero entered production unchanged. The reasoning was not irrational given the context of 1940. Japan's likely opponents, China, potentially the Soviet Union, did not operate fighters capable of forcing the Zero into high-speed engagements. At the altitudes and speeds where combat was expected to occur, the aileron limitation was irrelevant. The Zero's performance envelope was calibrated for the war Japan expected to fight. What no one in the procurement chain accounted for was the war Japan would actually fight. By December 1941, the Zero was the most operationally experienced carrier fighter in the world. Its pilots had logged hundreds of combat hours over China. When they arrived over Pearl Harbor, they flew with a confidence built on 18 months of consistent air superiority. The Americans they encountered were the Grumman F-4F Wildcat and the Curtiss P-40, aircraft that, in a turning engagement at low to medium altitude, had no answer for the Zero. But American pilots adapted faster than the Navy anticipated. The intelligence breakthrough came from an unlikely source. In June 1942, a Japanese pilot named Tadayoshi Koga was hit by ground fire over the Aleutian Islands. He attempted an emergency landing on Akutan Island. The landing gear collapsed. Koga died on impact. His Zero came to rest upright in a marsh, nearly intact, invisible from the air, and undiscovered for a month. When a U.S. Navy patrol found it in July 1942, they understood immediately what they had. The aircraft was shipped to Naval Air Station North Island in San Diego. Engineers from the Navy, Grumman, and Lockheed examined every system. They found the aileron problem in the first week of testing. They found the unprotected fuel tanks. They found the absence of armor. And they found something the Zero's combat record had concealed. The aircraft that was nearly impossible to defeat in a turning fight at low speed was straightforward to kill if you refused to turn with it. The tactical doctrine that followed was built on two instructions. Do not turn with the Zero. Do not let it dictate the engagement. Dive, fire, and extend. Use altitude, use speed, use the fact that above 400 kilometers per hour, the Zero's pilot is fighting his own aircraft. The Grumman F-6F Hellcat, designed in part around the specifications revealed by Koga's aircraft, entered service in 1943. It was heavier than the Zero by nearly 1,000 kilograms. It was slower in level flight. It could not turn with a Zero at low speed. It did not need to. It had 6 millimeters of cockpit armor, self-sealing tanks, and an engine producing 2,000 horsepower. When a Hellcat pilot dived on a Zero and fired, the Zero burned. When a Zero pilot dived on a Hellcat and fired, the rounds that would have killed an unprotected pilot were stopped by steel that weighed less than 10 kilograms. The exchange rate tells the story without ambiguity. In 1942, Japanese pilots were killing American pilots at a ratio that made senior Navy commanders uncomfortable to put in writing. By 1944, the ratio had inverted so completely that American pilots referred to engagements with Zeros as the Marianas Turkey Shoot. In 2 days of combat over the Philippine Sea in June 1944, Japan lost 476 aircraft. The United States lost 130.
The Zero had not changed. The aircraft entering combat in 1944 was structurally identical to the aircraft that had attacked Pearl Harbor. Horikoshi's team had proposed upgrades, more powerful engines, armor, self-sealing tanks. The proposals were approved too late, produced too slowly, and delivered to pilots who no longer had the training hours to fly them effectively. The Navy that had told Horikoshi to make the impossible possible had then made it impossible to fix what the original compromise had broken.
Jiro Horikoshi survived the war. He spent part of it trying to fix the aircraft he had built. The A6M Zero, the Zero's intended successor, designed with armor, self-sealing tanks, and a corrected control surface, flew for the first time in May 1944. Production was ordered, factory capacity was allocated. An American bombing raid destroyed the primary manufacturing plant 6 months later. Fewer than 10 repus were completed before the war ended. Horikoshi wrote about it afterward. His memoir, published in Japan in 1954 and translated into English in 1970, is a precise and largely unemotional account of the engineering decisions behind the Zero. He does not defend the choice to remove the armor. He explains the constraints that made it inevitable. The distinction matters, and he was careful to maintain it. The Akutan Zero, Koga's aircraft, the one that told the Americans how to kill the Zero, was repaired, test-flown over 190 times, and eventually damaged beyond further use in a ground accident in 1945. It was scrapped. No complete original Zero survived the war in flyable condition. Several have been restored since, rebuilt from parts recovered from Pacific crash sites and jungle wreckage. The best preserved example flew at air shows in the United States until 2019, when it was damaged in a landing accident in Illinois. It has not flown since. Here is what the Zero's story actually is. It is not a story about a great aircraft that lost. It is not a story about inferior pilots or inferior strategy. It is a story about a design philosophy that treated human survival as a variable to be optimized away, and about an institution that accepted that trade without fully understanding the cost until the cost was irreversible. Horikoshi built exactly what the Navy asked for. The Navy asked for the wrong thing. The pilots who flew it were the best carrier aviators Japan had ever produced. The aircraft gave them everything, except the one thing they needed when the war changed: a way to come back.